All right, guys, welcome back. Ladies, too. Welcome back. We're doing vertical stretch and shrink. Okay, vertical stretch and shrink. So, what this is, I'm going to actually talk about it a little bit more in the abstract sense first. So, one thing that I hope you guys may have realized is that before, when we had f of x plus a versus f of x plus a with a bigger than 0, okay, this moved left, moved up, okay? So in some sense, it was sort of counterintuitive. Okay, the same sort of thing's gonna happen with vertical stretch and shrink. So this, let me move this out of the way. This was the horizontal stretch and shrink, or horizontal shifts. So this one, I sort of think it may be a little counterintuitive. I mean, maybe it's not counterintuitive, but you need to think about it a little bit. So the same sort of thing is going to happen with stretch and shrink. So let's take A to be bigger than 1 first. Okay? So f of ax, okay, this is going to be a horizontal compression. Actually, I should change the name of the title of this to vertical and horizontal. Okay, so if A is bigger than 1, f of ax is going to be a horizontal compression. A times f of x is going to be a vertical stretch. Okay, if A is between 0 and 1, okay, then f of ax is going to be a horizontal stretch. Okay, and A of f of x is going to be a vertical compression. Okay, let's think about what that means first. So let's do an example. That's always good for thinking about what things mean. So the example is actually going to be my favorite function again. We're going to do a little bit of stretching on it. We're going to stretch my favorite example a little bit, or maybe compress it a little bit. We'll see. So let's start with y equals x squared. I'm going to be very, very diligent about it. Okay, so 0, 0. 1, 1, negative 1, 1. Let me actually erase that to be a little bit better as far as, there we go. 1, 1. Then 2, comma 4. So I'm being very diligent here about my y equals x squared. Okay, now let's take y equals, let's do it in blue, y equals 1/4 x squared. Okay, so this, the 1/4, okay, a equals 1/4 is less than 1. And so we're going to have a vertical compression. Okay, a vertical compression. And let's see what happens. So now, when x equals 0, they're the same. But at x equals 1, when x equals 1, instead of getting 1 as output, we get 1/4 as output. Okay. And instead of getting 4 as output at x equals 2, right, we're going to get 1 as the output. So what's happened? What's happened is we can imagine that we have a giant. Okay, we can imagine we have a giant. Okay, that's got huge hands up here. Okay, at the infinite end, and decided that they wanted to push down on this. So they're compressing this down to get to that other one. I wish I could deform it nicely, but I can't. Okay, but now there's actually another way to look at this. Let me actually make that a little bigger. Okay, so there's another way to look at this. Okay, this is also equal to 1/2 x squared. Okay, so if we look at it this way, so remember here, this was, of course, a vertical compression. That's looked at from this perspective. But we can also look at it from this perspective, at which it is a horizontal stretch. Okay, so our giant can maybe come at this end on the sides and decide that they want to pull out this way. Okay, so if they want to pull out, then you're eventually going to get something that looks like the other graph. Okay, so that's how a horizontal stretch and a vertical compression can sometimes give you the same result. All right? Okay. See you guys in the next video.